Okay, so basically what I'm gonna talk about is this box here that I have on this table here. So I'm gonna take this and I'm going to take the lid off. It has these like spokes coming off of it, but we're gonna put those over later. But hang on, I've got this. Right. So you got these rings. In the box. Now, basically, these rings are called Towers of Hanoi, and I'm gonna show you what Towers of Hanoi is. I'm gonna show you how I'm gonna solve Towers of Hanoi, and then I am going to solve it. I've actually come up with something where you can see. I'm gonna set a timer, and I'm gonna attempt to solve it in 9 minutes. Okay, so Towers of Hanoi, what you do is you take the rings and put them into a tower. Makes sense. There. So you made a tower. What you do with this tower is you try to move the tower onto a different peg. There's a rule about how you can do this. You can only move one disc at a time. So you can only move one disc at a time, like this, for instance. You can only move the top disc, so you can't like slip a disc from anywhere else. And also, if you have something like this, you can't do this, for example, because then you can't move a larger disc on top of a smaller one. Alright, so that's what Towers of Hanoi is. And what I'm going to do is I am going to show you a strategy for solving. So to work out this strategy, what I'm going to do is I'm going to just increment upwards. There are rings. Now, I'm actually just going to move these behind the thing so you can see this thing better. Stop yet? Okay, I don't know, that was just like, let's start with 0 rings. Well, for 0 rings, well, we just solved it, right? For 1 ring, well, you can obviously move it onto a different peg by just doing this. There. Okay, so now, 2 rings. There. How can you solve 2 rings? Well, it starts to get not really obvious, but it turns out you can do it in 3 moves, and you can't do any better than 3. I'm gonna show you how. 1, 2, 3. Might not seem so obvious, but you can do it that way. And you can kind of see how this works, right? You can move this thing out of the way, so you can put this thing on top of there. And then you can move this thing on top. And so there. For 3 rings, it starts to get interesting at this point. So for 3 rings, what you do is this. You can actually do it in 7 moves, and you can't do any better. So I'm going to show you how you can do it in 7. Can be done in 6, but it can be done in 7. So I'm going to show you how to do it in 7. 1, 2, 3. Now we move this thing to there, so we can move this one. That's 4. And then we can move this one over to there. 5, 6, 7. So we can do this in 7 moves. What about 4 rings? It turns out you can do it in 15. And you can maybe calculate this in general. Well, what you can do is move this thing over, so it takes 7 moves, and then, so I'm gonna just do that right now. Then we move this thing over to the peg there. So that's another 1 move. And then another 7 moves to move this thing again. So it's 7 plus 1 plus 7, so it's 15. I'm just gonna complete this just so everyone is happy. There we go. We moved the entire 4 tower. For 5 rings, what we can do is move the 4 tower, which takes 15 moves, and then to move the another disc, and then move the 4 tower again, which takes another 15 moves. So in general, it's twice the previous one plus 1. So, and this is the solution for 5. That's okay. So 6 moves. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. There we go. We can do better than 31, but you can do it at 31, as you can see. Another way to figure this out is instead of a recursive definition, so in order to do n plus 1 rings, you could do it in twice how much you could do it in n rings plus 1. You could actually just come up with an explicit formula. By definition, the explicit formula is 2 to the power of how many rings there are minus 1. So we could just go straight to 9. Because, look, 9, 2 to the 9 is 512. Minus 1 is 511. Okay, 511 moves. So it's 511 moves in order to complete the version with 9 rings, like this. Hang on. Hang on. Bathroom break. I'm gonna be back in a second. Okay, we're back. So, what I'm gonna do is just put on the, I'm gonna go over the table here and I'm gonna open up this. So, what have I done? Oh, hang on. So, I don't know the volume works. Okay, so I got a stopwatch over there. I've actually practiced over there at the table, but anyway. And what I'm gonna do is I'm gonna attempt to solve this in 9 minutes, because that's what the video is about, I guess. So, okay, so if you're ready, set, go. Wait, I messed up. I don't know.
Just do as if you start again. But you should put the...
Reset the timer.
You should... Мы просто вырежем всю эту среднюю часть. Когда ты в туалет ходил, и когда у тебя не получилось решить. Ты подумай для себя сначала, Семечка, в чем была твоя ошибка.
It says stop recording, so I think it's still recording.
It's still recording. It will just cut this part out, right?
Yes.
We can do it and film more.
Yes, okay. Okay, so now what we're going to do is we're going to attempt to solve this in 9 minutes. I've got, okay, I got a stopwatch, or actually, I'm gonna use a timer here, but I'm too afraid for a timer, so yeah, I'm gonna just use a stopwatch here, and I'm gonna see if it reaches 9 minutes before I solve it, because isn't that what this video is all about? Okay, so if you're ready, set, go. Oops. Oops. already kind of tired. Whoa! Low battery. I'm hurrying. Will we get there before the battery gets to zero? Whoops! I've Oops. Oops, I moved it the wrong way. Halfway through. This is going remarkably well. Mom is gonna tell me if the video is gonna stop.
It's not stopping yet.
Whoops, I have to move this thing over there. Have I messed up yet? I don't think so. I have to keep this like rhythm in mind. So, I'm a little bit worried if I mess up. Oh, I've reached 9 minutes.
Don't worry about it, just go on.
Okay, I think new time mark will be 15 minutes. And this is not about time anyway, as I said in my previous video. I think I got something. Whoa, 3/4 of the way through! I think this is like a meme video to the Vsauce video.
Don't get distracted.
I'm not getting distracted. The meme video to the Vsauce video, and the coding trainers actually also made a video, which is the meme video, but that I've gotten the move right. Stop recording yet. There. 7/8 of the way through. Have I messed up yet? Almost there. Battery. But I shouldn't really. Wait, I messed up. Where was I? There we go. I messed up. I've reverted back a few moves, and I think... Almost there! Yay! It was like 14 minutes, and I have solved it. 511 moves, and I finally solved it. Yay!
You had calculated it wrong originally because you were thinking that you would make fewer moves per second. But the number of moves was correct.
511 moves. Phew. A full thing solved. I think I should like high five because it's. I think I'm the first. Like I don't know. This is like a meme
We'll put some music on.
video. There are a few more things to mention about this, and I think we should make like a part 2 video.
Nah, just say it here.
Just say it here. There's some other things. So first of all, I missed some things about the strategy. So I've missed some things about the strategy where basically you start them off all in the middle. So you start them all off in the middle. Let me just get rid of the annoying stopwatch thingy. so you start them off in the middle. And then what you do is you basically every other move. What you do is you move this the 0th disc around, so the smallest one. For all the remaining moves, half of those you move the second to smallest disc. For the remaining moves, half of those you move the third to the smallest disc. For the remaining moves, and so on, all the way down to the bottom. In the bottom disc, that's actually the most interesting one, I think. You move it only once. So you move it only once when you move it to there, right at the halfway point. So that's another thing. Another thing is I have watched a video, the 3 blue 1 brown video on this, which we could maybe mention in some sort of like end screen thing, and at the like end. And then what I have done is I've learned about this other version of the game, the constrained version, as I call it. So I just played the basic version for you there. Basically, when you have when you're playing the constrained version, it's already hard to do with like 5 rings. So yeah, it's basically the same as the basic version, but it has an extra rule. The extra rule is you cannot go and take a disc and jump across like this. So you can't. So each disc can only move to a neighboring peg. This is surprisingly harder to do. Well, it is obviously harder to do, but how much harder is a really big factor. So the basic version of the game you can do in 2 to the power of the number of rings minus 1 moves. The constrained version you can do in 3 to the power of how many rings minus 1 moves, which is actually dramatically bigger. So it's and why I'm gonna show you, because the strategy, what you do is you 2/3 of the time, so you just go like this. So I'm gonna play the constrained version out for you. You can see if it figures it out. So you go 1. No, that doesn't work for me. So what you do is you go 1 there, and then 1, 2, 1, 2. No, sorry. Basically, what you do is you go 2, 3. 1, 2, 3. 1, 2. No, hang on. This thing is actually easier if you start on the left peg, because then you have to keep this like factor 1 in mind, and then everything gets really messy. But anyway, when you start on the left, you go 1, 2, 3. 1, 2, 3. 1, 2, 3. Because the third time you move this disc, and then you go 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And so on, right? And I'll just complete it. 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2. 3, 1, 2, 3. 1, 2, 3. 1, 2. Well, and so on, right? And you can see that the strategy is a little bit, yeah. The constrained version is nice because it actually not only gives it the shortest possible path, it will actually hit every single combination. It will actually hit every single combination of rings that's possible. Which is a bit strange. You can show that. Maybe the 3 Blue 1 Brown video will explain. However,
so it's like a super permutation?
It's actually just a permutation. It's a permutation of all of the possible combinations of the discs and the pegs. So it's a permutation of permutations, or a permutation squared, as you might call it.
I remember you made a video once about how it's also to be solved with using binary and tertiary numbers.
Not tertiary, ternary.
Ternary.
3 Blue 1 Brown will explain how this is linked to binary and ternary. And what I'm gonna do is I am going to at the end of the video, I'm going to show you the 3 Blue 1 Brown. Thing. And
you've already made a video about that, like I think a year ago or something. How it's connected to binary. You can just give a link to that.
you can just give a link to both videos. Okay, so one more thing I want to see. With the 9-ring version, how much do we have for the 9-ring version? How many moves do you need to get to the constrained version? So what I'm gonna do is I'm gonna just get to this scene here, and what I'm gonna do is I'm just gonna take this. So timer. So what I'm gonna do is I'm just gonna look up 3 power it's heating up. 9 minus 1. 19682 is the answer. Which is a pretty big answer.
We're not gonna film that.
We're not gonna film that. It would take about 5 hours. Which means that we should probably not actually record me doing this, because it's actually just too boring. Just sitting here for 5 hours trying to solve my puzzle here. So,
should we wrap it up here?
I think we should. Oh, and by the way, I'm gonna show you a couple of videos here. This is a mean video to this video here, and the 3 Blue 1 Brown video that I mentioned is here. You can subscribe to my channel here, and maybe there's a video over here that will explain how this is linked to binary and ternary.